Problem is jumping through the segment. This is the code forces problem. In this problem, the we have given the n level of the segment, and in each of the basically segment have the given coordinate li and ri. Li the starting the starting in static coordinate of the starting value of the segment, and the ending value of the segment is ri. And then initially the player has level at coordinate 0, 0, and in one move basically he can move the distance less than or equal to k. So in ith move, in each move the player move the other segment. So in after the basically given is the after the ith move, the player must be land in the ith segment, which is at coordinate x lie in li to ri. That means basically we have given that in first move we inside the segment 1. In second move we lie in the second segment in range of L2 to R2. In the ith move we reach the segment nth segment in lie of Ln to Rn. So we have to find the minimum value of k, so that we can able to reach the nth segment. So the approach of this problem is basically for each k, for basically we have for given at we have to calculate the minimum value of k. So for if we calculate the if we calculate calculate for k, we can if we achieve the basically at the last index using value of k, then we also able to reach k plus 1, k plus 2, and so on. But using the k minus 1 we cannot reach the last segment, because k is the minimum. So we have to using this we can apply the binary search, and for each k we can able to reach the nth segment or not. We calculate, we check for each k, for that k we can able to reach the last segment or not. If we can able to reach the last segment, then we decrease the the k, and then if we cannot able to reach the nth segment, then we increase to k. We apply the binary search like low and high. If we can able to reach the nth segment using k, then we assign the high is equal to k minus 1. If we are not able to reach the given value k, then we have to calculate the for k greater than k. So we assign low is equal to k plus 1. So we can able to for each k we have, and then we have to check now for each value of k we can able to reach the last segment or not. So we have to solve in OFN. The total time complexity is equal to the basically in n log n. We can say n log n, or value or we can say the or we can say maximum of we can say maximum of L1 to R1 into log of n into O of n. So we can solve using binary search of this problem. So the solution is, so simple solution is here. For here we are taking the input of the array, and we store the L1 and L1 Li and Ri in the pair. So initially in the problem is given that initially the player at 0, 0. So we put the at 0th index we put the 0 comma 0, and then for index 1 to n we put the L1 to R1 using in pair. And then we have to apply the binary search. If we apply the binary search here, and for each k, if we calculating the k, the middle value, and then we check if for given k we can able to reach the last index or not. And then if we able to reach the last last segment, then we assign the high is equal to k minus 1, otherwise we can assign low is equal to k plus 1. At the last we can print the low. So here so we are implementing here, we have to now implement the good function which check for given k we can able to reach the last index or not. For that, here we taking the for checking that we basically we now we checking in reverse manner. Now we assign the now if we can able to reach the last index, last segment, then our range is our range lie between the last segment, that is the ln and rn, that is the last segment of last segment, the index, the value of last segment, the first value of last segment, and the last value of the last segment, second value of the last segment. So we calculate the basically we have to reach the last segment. So last segment in any point of in that range. So for that for now we checking the in reverse manner. Now I can basically I can we now if we the at the last index, then we can able to move the we can able to move the adjacent adjacent segment or not. For that we checking here, we calculate the range if left minus k, and we calculate new range L1 and L and R. We are calculating the new range, that is L minus left minus 1 and R is equal to right minus 1. So here the new range is L to R. And now in the in basically in that range, L to R, we can able to reach the range in left to right. So now we are checking the L and R is in the ith segment, ith segment lie in the L in range L to R or not. If here we are checking the both of the segment intersection or not, so that if both are in both the in segment are not intersecting, then we cannot reach the last segment. So we have to return the false, otherwise we can move if we can calculate the new range. So here the new range is the maximum of v of I dot first, and that is the li comma l, and right range right value is minimum of r to ri comma r. And then we in this we can able to reach the at a 0 at the start, then we can able to then we can able to reach the last nth segment as well also. So here we checking the here we attach from last segment to 0th segment. So if we able to reach the nth segment to last segment, then we have to return the here true. Yeah.